Alright, so now let's have a look at some different equations here. Maybe we can take a look at some of these systems and see what's going on. So in our first situation, we have something that looks like this. 3y minus 2x equals negative 6, 24 equals 6y minus 4x here. This looks pretty good. I think one of the first things we note here is that we can probably rewrite this equation here. Let's go ahead and rewrite that. I'm going to switch the order of the pieces here, so you get 6y minus 4x equals 24, and 3y minus 2x equals minus 6 here, okay? Now we note that I see the coefficients here, 3 and 2, 6 and 4 are the coefficients here, so it looks like I can go ahead and actually multiply this top one by 2, or I can divide the bottom one by 2 here. Let's divide the bottom one by 2, because everything here is even. So we can do that here, and we get 3y minus 2x equals 12, and 3y minus 2x equals negative 6. Uh-oh, wait a minute. You look at this, and that tells us negative 6 is equal to 12. What? So you look at this equation here in this system and you get something that doesn't make any sense. So I guess one thing we can try to do is we can try to see what's going on here. Maybe we can have a look at this sort of graphically, right? We sketch this here, right? Maybe we can see what's going on in our thing here. So in this situation here, let's take a look. Let's see, we have 3y minus 2x is equal to negative 6. So that becomes 3y equals 2x minus 6. So y is equal to 2/3 x plus 2, right? So this first equation here, this top one, is going to be a line with slope 2/3, and it's going to come out of the point x equals 2. Come along here, the y-intercept is going to be 2. So this is 3y minus 2x equals 6, right? Now the other one here, we can do the same thing with that. Let's go ahead and write that one out. So there's going to be 3y minus 2x is equal to 12. And I think you know what's going to happen here. You get 3y is equal to 2x plus 12. So you get y is equal to 2/3 x plus 4. So now we get an equation that looks like this here. So actually it's going to do something like that. But notice that these two lines are parallel because they both have slope of positive 2/3 here. So this is this here is going to be 6y minus 4x equals 24. So notice that these equations are parallel here. These lines are parallel. That means they have no intersection points. And if you think about it, it makes a lot of sense here, right? If we went back to this here and graphed these equations, they're going to intersect at a point. In this case, 6 and 1.5. This coordinate 6, 1.5 is going to be it's a value that satisfies both equations here. That's not going to, and in this situation we don't have that. So in this case here, these are parallel. So this we refer to as what is known as an inconsistent system. Here we have no solutions, right? There are no solutions to this system of equations because the lines are not going to meet at any place here. Here we have, if we were to draw this and graph it out, we would have, an intersection point at 6, 1.5 here. This is known as a consistent system because there's one solution. Okay, there's exactly one solution here, so we refer to this as a consistent system. Okay, here we have an inconsistent system where there are no solutions. All right, let's have a look at this system now. The second one here, we have this. So we're going to go ahead and set this one up here as well. So this one looks like I'm going to have to gather some terms. It looks like here I can go ahead and put all the variables on one side. So let's see. I have a negative 2u. And then we have, let's see, 10v minus, so there's a 4v on this side. I can push that to the other side, so this becomes, so subtract 4v on both sides, subtract 4v, subtract 4v here, these go away. We're left with a positive 6v, and that's equal to 16 here, right? And then we can just carry this one over, so it's negative u plus 3v is equal to 8, right? We can go ahead and do this here. Looks like, again, everything is even, so I can go ahead and divide everything by 2. So I divide everything by 2, I get negative u plus 3v equals 8. And then negative u plus 3v equals, Yet again, we have something that makes, we have a weird thing here, where instead of before where we had a completely false statement here we've got a true statement, right? Because you get 8 equals 8, and that's always true. So note that these two equations are in fact actually one and the same. And if we were to graph this in the UV plane here, right? So we can say that this is u, this is v here. This equation, right? This becomes 3v equals u plus 8. So v equals u over 3 plus 8/3. So again, so now we're going to have a line that looks like this here. It turns out both of our equations are going to look something like this here, right? Both of them actually are this entire line here, right? So in fact, there are infinitely many solutions. So notice how in this situation here, this, if you take a look at it, this is really, because I can factor the 2 out of this. This is really 2 times negative u plus 3v equals 8, right? So notice how this is actually some constant multiple of the top equation here. So we end up with something that looks like this here. This, what we have here, this is known as a consistent system. Sorry, not a consistent, I'm sorry. This is known as a dependent system. Okay? It's dependent because, as you can see here, one of the equations here is actually an integer, is not necessarily an integer, but it's a constant multiple of the other equation here. So in fact, these are in fact one and the same line, just written in a slightly different way here. And indeed, there are infinite. So in this case, we have infinitely many solutions. But note that just because there are infinitely many solutions doesn't necessarily mean that we can just pick numbers willy-nilly here, right? We can take a look at this here and try to actually express this. So notice that we have this here. So we have u is equal to negative u is equal to 3v plus 8. So I can rewrite this. I had this here. Let me go ahead and mess around with this. So negative u plus 3v is equal to 8. So we get negative u minus is equal to negative 3v plus 8 here. So we divide everything by negative 1. We get u is equal to 3v minus 8 here. So notice that this tells us that u is equal to 3v minus 8, and that actually gives us a thing here. So every solution has to satisfy this equation here. So that means our solutions are going to be infinitely many, but if we want to write them out, it's going to be of the form k comma 3k minus 8 for any value k here, right? So k is what is known as a parameter here. This is just something that we have complete control over. And note that in this situation here, we can see that the x and y, the u and v coordinates here, these are related by this fact here. If you have u, then v is going to be 8 less than 3 times u. And that's how we note here all of these solutions, anything on these lines will satisfy that here.